Hello students and welcome back. You should have been working on this on your own part, okay? Coming in back, and I will explain here through kind of my work and what I would say are the answers. Now, I realized after finishing the video that I made a mistake last time. If you caught the mistake, great for you. Extra point. Let me know if you catch the mistake. I'll give you a little extra point there. My mistake here was that if you notice, then when we set up this graph here, okay, what kind of slope does it have? Does it have positive or negative? It has negative, and I forgot to mention that it is a negative slope, okay? I even explained that down in here. It goes down by 1, but yet I forgot to mention that the slope is negative here. My apologies, guys. Sorry for that. Let's go back and look at then this on your own here, okay? So for this on your own, first thing you need to do is create a scatter plot of the data and draw the line of best fit, okay? So here is mine. I'm going to make this a little larger actually, okay? Here is mine. Again, making sure to label things. So I just said festival attendance. Here's the years at the bottom. Your attendance then is on the side, okay? I decided to use my line of best fit a little bit lower down here. I know I have data points that kind of go up over here and then over here as well. But again, I wanted to kind of even it out since there's a little bit 2 down here, 2 below, there's about 3 above. It's fairly even on that sense, okay? Another thing I can notice all the way about at the top about this one and why I decided not to use this data point up here is because this is probably an outlier. It's so far away from everything else that it just skyrocketed, okay? So making sure you label everything, I went up by increments of 1 on the x-axis and then increments of 100 on the y, and I started at that 400. So I used that little squiggly line, okay, if you can tell, to kind of jump from 0 to 400. The next part of it was to find your equation of the line. Now, your equation of your line and the best fit line is going to depend on how you set it up, okay? In the case of mine, I went through the point 0, 420, almost about 4 and that 900 and pretty much that 5 and 1100, okay? When I did that, I get a slope of about 2 and I get a y-intercept. I would assume it's probably 0. So that's why I came up with the equation y equals 2x plus 0, or you could just say y equals 2x, okay? Let's take a look at some of those other problems you had to finish up. So finding the slope and the y-intercept of the line of fit, so interpreting those. So your slope means that, again, that's that change in the y out of the change in the x. And I said my slope was 2, okay? In this case, it's going to mean 200 because I went up by increments of 100. So my slope is really meaning that 200 every year. So it means that my attendance is increasing by 200 each year, okay? And then your y-intercept of your line, again, I went and said that my y-intercept is 0 because think about it. If you have 0 years, because y-intercept means that x is 0, at 0 years, is anyone going to be attending your festival? No, no one's going to be there. So my y-intercept means if there's 0 years of doing it, there's 0 people attending it, okay? And the last part is predict the number of people who would attend the festival in year 10. Now, given my data, okay, again, let's look at this. Ooh, it's kind of falling off here. Sorry, guys. Let's fix this. Okay, given my data and that kind of outlier piece, I could follow my line of best fit, but I can kind of also know that it's kind of curving up, okay? Given on that, I would say that my best guess is still going to be on that line of best fit. So where does my line of best fit continue on till 10? I would say on my end, at least, it looks to be about 1,950, okay? And again, it's a prediction. It may not be super accurate, but as long as you're making an educated guess based on some of this data that you have been given, okay? And how did you figure out your line of best fit, okay? Let's keep moving on. All right, Here is our next one, okay? The next problem here says the table shows the worldwide movie ticket sales of Y in billions of dollars from 2010 to 2011, where X represents the year 2000. So X equals 0, sorry, represents the year 2000. Use a graphing calculator to find an equation of the line of best fit. Identify and interpret the correlation coefficient, okay? So line of best fit, identify and interpret the correlation coefficient. That is my directions right here, okay? It's also important to know that my Y is telling me about, movie ticket sales. And then my X is talking about the years, okay? But that X equals 0 represents that 2000 and 2000, okay? Here is my data points as well. Now, I know that we don't have a graphing calculator, and I would really love to have been able to teach you this on a physical graphing calculator, but I know that's just not the case right now. You actually slightly luck out on this because it's really hard to set this up on a graphing calculator. There's a lot of different steps to set up on a graphing calculator to set up your data points, to make this line of best fit. Last year, I gave students a whole page worth of directions on how to do this. So I'm going to show you a way to do this online using an online graphing calculator, okay? Give me just 1 second here. I'm going to kind of switch to the graphing calculator here. So just give me 1 minute. All right. So the best graphing calculator I have found, and a lot of students do use this, sometimes I've even linked it to your big ideas, is this Desmos, okay? So if you Google Desmos, this is what you're going to see. I want you to pick the graphing calculator option here. Okay, I'm going to probably extend our page here just a little bit. Let's go with this for now, okay? One thing within this graphing calculator here is that I have a couple different operations that I can do, okay? So if you press this little button right here, just like you saw, okay, you're going to come up with all these different options on different kind of graphing things that you can do. What I want you to do and scroll down to is, let's see if we can find it. All right, is this, I think it's that statistics line plots, just a point, cent line. Yeah, it's going to be that statistics part, okay? So I'm going to go back up to that. I went a little too far. Let's go to this statistics line regression. So we're going to click this option, okay? What we're going to do is we're going to say yes. We're going to open graph, okay? And now it's already kind of created a graph for us, okay, as you can see here. I don't want this graph. What I'm going to do is I'm going to take those data points that we were given in this problem, and I'm going to rechange this, okay? So for right now, let's get rid of these. Let's just kind of delete them and fill in as we feel necessary here. So we're just going to get rid of this. Goodbye. Bye. Okay. So go ahead, you can go back in this video, pause that part of the graph, or look at your notes and fill these in. This is your X column, here's your Y column. I'm going to pause the video for a second. I will come back and have this filled in. Alrighty, so now I have set up my scatter plot here. What I did on this side over here, just entering in all my data points, okay? And it has now created a data point for every single one, okay? The other part with this is that it creates your line of best fit, okay? Here is my line of best fit. As you can see, it's this orange line that's going through all these data points, okay? Now, it is hard to read all of this, okay? So go back and think about your Y equals mx plus b. Here is your m value, okay? This is your, it looks to be 1.5. Now, just round it to the first decimal place, okay? Don't worry about every single little decimal here, okay? We just want to get fairly close. So in this case, I'm going to say that my m is 1.5. Start at 1.5x. And my b value here, let's just round this to 16.3, okay? Plus 16.3. Okay, and there's my line of best fit, okay? So what they asked for us is to graph this, is find your line of best fit. We found our line of best fit. Then the other part is to talk about that coefficient thing. Okay, so it says identify and interpret the correlation coefficient. Okay, this one I'm not worried that you write it out, but I want you to understand what this means. Okay, and that's this little R number right here. I know it's kind of hard to see. Okay, looking down at this bottom corner, this R number there where my mouse is. Okay. Ultimately, you want this number to be as close to 1 as you possibly can, okay? 1 means that it is very, very accurate, that your line of best fit is very accurate, okay? In this case, this is still fairly good because it's a 0.98. That means it's very close to 1, okay? As 1 as being, it's being 100% accurate, okay? So that's what that correlation part means, and to identify that, okay? So let's go back to these slides. All right, so we did this. We talked about our equation. We said y equals then 1.5x plus 16.3. All right, let's keep going then. So this one is an on your own, and this is the last part. What they want you to do is use a graphing calculator to find an equation of the line of best fit for the data in example 1. Okay, identify and interpret that correlation coefficient. So I want you to go back and use that Desmos website. See if you can set this up with the data from example 1. Okay, if you need that data again, look at your notes, or go back to the video from lesson 1 to figure it out, okay? Go ahead and pause the video, do what you need to get those answers, and when I come back, I will reveal to you what the graph should look like and what kind of line we should have. All right, welcome back. What I did is I just took that data from example 1, okay? Plugged it in, see where my line ends up, what kind of equation I'm creating, okay? Now in this case, they say that my slope is negative 1.8. Again, just round it, okay? And my y-intercept looks to be about 19.3, sorry. Again, this is where I'm seeing it right down here. Oop, right down here, okay? Now my correlation, again, is this part, and it's going to be negative, and that's fine because it's a negative slope, okay? Again, you just want it as close to 1 as you possibly can, okay? So again, we're getting about a 0.98. This one I may have got an 8.8, so it's a little more accurate. And as you can tell then, if I go back to the original slides, okay, we had talked about that this, what the original equation we had and what I had come up with was this negative 1x or negative x plus 18, okay. Once I actually plug it into that graphing calculator though, and we used that, we figured out that it is actually y equals negative 1.8. So I was feeling a bit off about that slope, but maybe it should have been closer to 2, plus 19.3. Okay, so doing it manually is a little more tricky. You may not get it quite as accurate. And that R value or that correlation coefficient may not have been as close to 1 given this, okay? But here is the equation that I have created given the graph, all right? Let's keep going. We're done. Sorry. So again, don't worry about these workbook pages right now. Use them as extra practice if you've got it and you would like to get them done. But your homework then is going to be this 9.2. So hard for me to write on here. Sorry guys. 9.2 on Big Ideas Math. Okay. So make sure you are getting that done. Again, make sure, let me know if you've got any questions. If you're not sure if you're doing it right, so on and so forth. Reach out to me as much as you can. Meet me on Zoom if you need to, whatever. Okay, I'm always here and available for you. See you guys later. Bye.